Hello and welcome to the Dragon spacecraft. You are here with the Polaris Dawn crew. My name is Anna Menon. I am one of the mission specialists and the medical officer for our mission. This is Kid Poteet. He is our pilot. Jared Isaacman is our mission commander, and Sarah Gillis is our mission specialist. And we are so excited to talk to you today about some of the science and research we are doing on board here. We have had a full complement of research, an action-packed schedule for this mission. We've had about 40 science and research experiments that we have been tackling, and they span all sorts of genres, and we're really excited to talk to you about a few of them today. So to kick us off, I will start telling you about some of the ones that I love. So right here what you see, this is a butterfly ultrasound device, and it's really neat because it can work with like an iPhone or an iPad or just any sort of like tablet device, and so it's really portable and you can take it anywhere, even to space. And you're able to actually image all sorts of different pieces of the body and get really good diagnostics through it. So we've been using it for a whole bunch of different experiments, measuring our different veins. We've been measuring our bladder. We've been measuring our kidneys and liver and a lot of different pieces of the body. So it's been really interesting, and we're excited to see what we learn from all the data. Then this right here is another type of ultrasound device. This is a novel three-dimensional ultrasound, or the optic nerve sheath. That's a portion of the eye, and what's really interesting about this is it gives us insight into the fluid shifts and the eye issues that plague astronauts when they go to microgravity. And so scientists are really interested in the changes that happen to this optic nerve sheath, and this three-dimensional ultrasound is a brand new technology. You can use it, and it gets you really efficient, good images of that sheath. So hopefully we'll learn a lot more about those vision changes. And I'll hand it over to Kid to take it from here.
Hi, everybody. So the two experiments that I really enjoyed participating in, first off, the LEO plant. This was created by the U.S. Air Force Academy, which is near and dear to my heart. I was assigned there many moons ago as one of the commanders of the cadets. And what these cadets have created is a casing that holds different plants, and we've been imaging these plants on a daily basis to see what the impact of zero gravity is on this plant. And then one other experiment that we completed today is an airway assessment. So one of the big concerns is the fluid shift up here at zero gravity. We can really feel the effect as soon as we were on orbit, and you can kind of see it in our faces. So one of the concerns with long-duration space flight is to be able to triage in case of an emergency. And one of the first basic steps is airway assessment. So we volunteered to do some imaging of our airway. We did this experiment before flight, during flight, and then we'll do it post-flight. And what this requires is us to numb up the nasal passage and then insert this endoscopic camera all the way through the nasal passage and back of the throat to take these different images. And then post-flight, we'll be able to assess what happened to the airway passage as that fluid shifts. So those are two of the experiments I participated in, and I'll pass it off to our commander.
Hey everyone, so I'm pretty excited about this experiment right here. This is a Tempest Pro, also called our ambulance in a box. So, if you believe in SpaceX's vision of making life multiplanetary, that we're going to have thousands of starships in space someday, tens of thousands of people, we're on Mars, and we're exploring our solar system, it's pretty cool, but those are some pretty long journeys, and hospitals aren't very close by. So we have to be able to bring diagnostic tools into space with us, and then be able to beam that information back home to the flight surgeons. So just yesterday, we hooked up all sorts of cables to this this, so blood pressure, SpO2, respiration, EKG leads, and basically we're able to capture a number of vital signs and test it out. And then today we actually did a full-blown medical simulation of what could be a very likely medical situation that could develop after an EVA, and then was able to beam a lot of this information home via Starlink to the flight surgeons in mission control. So I really am excited about it because it's this kind of technology that's going to be needed, to kind of further humankind's ambitions to explore among the stars. And I'll turn it over to Sarah, our mission specialist.
Hey everyone. So we've been doing also, as Anna mentioned, a lot of research into spaceflight-associated neuroocular syndrome. And so I've got a couple of devices here, quick see, and floating away from me. And a pupilometer here. But we've been collecting data kind of every day, looking at the changes in our vision over time in space. We also have an experiment from CU Boulder that we did shortly after arriving on orbit, where you actually put a contact lens into your eye to monitor the pressure change over time. And there's a picture of Jared. He has the contact lens in his eye that's sending pressure data over 12, 24 hours to a sensor. But he really looked like a rogue space pirate with his eye patch kind of covering it, so he didn't have to have some vision changes from that lens. But it was quite a look up here for the space pirate.
Awesome. Well, thank you so much for joining us today. That is just a brief insight into the wealth of science and research that we've been doing up here. We are so excited to gather as much data as we can for the scientists back on Earth so that we can learn together and contribute to our collective future for the future of human space exploration and on Earth as well. So we'll talk to you soon. Thanks. Bye.